Hello, my loves. Today we are continuing with the volume of composed figures. So just like yesterday, our standard is I can relate volume to the operations of multiplication and addition and solve real-world mathematical problems involving volume. Remember that volume is additive, which means you can find the volume of smaller pieces and then add them together to get the whole volume. So here in this complex figure, or it could be called a combined figure, it's called a composed figure or a composite figure, even irregular figure. If you break this figure down into three separate rectangular prisms, we can simply use the formula length times width times height in order to find the volume of those little prisms. Then we can add the volume back up to find the volume of the entire figure. Here's our objective for today. I can decompose compound figures, find the volume of the smaller parts, and then add to find the volume of the whole figure. Your essential question: how is volume additive? Here are the lead measures for today. We have some more volume practice, a math on the spot video, a Khan Academy video decomposing irregular figures, and iReady teacher assigned lessons. Don't forget, you've got to do those 2 iReady lessons that I assigned to you. Those are going to be your grades for the week. Your third grade in math is your 50 minutes or more. And don't forget, in order for you to be counted as present for attendance, you have to have 50 minutes of math iReady and 50 minutes of reading iReady. All right, here's practice. Get a pencil and paper, and I want you to solve this problem. Cayman wants to build the largest possible toy box for his sister. Which of the dimensions below will result in the largest toy box? So we have 4 options, and we need to, solve everything. Yes, we need to solve all of these using that formula length times width times height in order to find out which one of these has the greatest volume. Go ahead and pause the video so you can do the math and find out, is it box A, B, C, or D? All right, well, let's see if you have the same thing that I have. For box A, we've got 2 feet by 4 feet by 1 foot. So it's 2 by 4 by 1. And we know that 2 by 4 is 8, and 8 times 1 is 8. So A is 8 feet cubed. Let's look at B. We have 3 feet by 2 feet by 2 feet. And we know that 3 times 2 is 6, and 6 times 2 is 12. So option B is 12 feet cubed, or 12 cubic feet. Option C, we have 5 feet times 2 feet times 2 feet. Did you get 20 for this one? Because 5 times 2 is 10, and 10 times 2 is 20. 20 cubic feet. And then for D, we have 4 times 3 times 1, and you should have gotten 12 feet cubed, because 4 times 3 is 12. So the answer, which dimensions will result in the largest toy box, is going to be option C. So Cayman's going to want to build that toy box 5 feet by 2 feet by 2 feet in order to get the largest toy box. Okay, here we go. Turn off our captions.
we've seen volumes of kind of regular type of shapes, like rectangular prisms, where we know its length times width times height will give us the volume, how much material is needed to fill up a particular shape. But actually, just knowing the formulas that we've been looking at, we can actually use those formulas to find the volumes of really weird shaped things. Let's have some fun by taking a look at a weird shaped object that Patty tried to figure out the volume for, and she was really, really close, but she made a little mistake. Let's see if we can learn from Patty and have Patty be our teacher. Let's check it out for ourselves. So Patty wants to find the volume of this particular solid. And so here's what she did. She added the values 2 times 3 times 11 and 2 times 3 times 10 to find the volume. And the question is, what mistake did she make? Well, I think this is a valiant effort. So let me tell you what Patty was thinking, and I really like her thinking. So here's what Patty's thinking. Patty says, you know what? These are actually two rectangles that are put together, rectangular solids. So all I've got to do is find the volume of each rectangular prism, and I will add them up, and that's the and, adding them up, and I'm all set. And what's the formula for the volume of a rectangular prism? Well, she knew that as well. She knew its length times width times height. And so check out what she did. She said, okay, let's take a look at this first rectangular prism. Well, it's 2 by 3. And then what's that length over here, right? What's the length over here? The length over here is going to be what? Well, she notices this is 8 centimeters, which is good. And she goes, oh, but it's not the whole thing. It's 8, and then whatever this little extra piece is. And what is 8 plus 3? 8 plus 3 is 11. So she takes 2 times 3 times 11, and that gives her the volume of this piece. Great. Now she wants to find the volume of the other piece and add them up. And what's the volume of the other piece? Well, the height is still 2. This is 3. And this here is 10. So she has 2 times 3 times 10. So this actually sounds really, really good. The problem that she made was this little area right in here. When she was clever enough to take the 8 and add the 3 to get the 11, she found the volume all the way to here. But then she found the volume all the way out to here. Do you see she kind of double counted over here, the volume? So her answer is actually a little too big. A better way of seeing this, and maybe the better way for Patty to see it too, would be to actually draw this picture to illustrate that we're going to actually cut this into 2 different rectangular prisms. And one way to see that is just to do that right now. So I'm going to cut this into 2 rectangular prisms by cutting this off right here. And if I do that, check out what happens. Now you can start to see it a little clearer. You see, this rectangular prism will end and just be 8 centimeters long, and then all of this will make up the second rectangular prism. Patty was actually finding the volume of this piece and this piece, and so that little volume was counted actually twice. So how would we find this and correctly? Well, the first thing we'd want to do is find the volume of this piece. Well, the volume of this piece is going to be what? Well, it's going to be 2 times 3 times 8. And so the first thing we're looking for the volume of just this piece alone is going to be, oh yes, 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 yes. The volume is going to be 2 times 3 times 8. And that works out to be 48. And what are the units? Well, they're centimeters times centimeters times centimeters. And so that's cubic centimeters, which I'll just abbreviate as CU/cm for cubic centimeters. So that's the volume of that little piece. Now we have to find the volume of that piece, which is just finding the volume of this. And again, it's just the volume formula, so it could not go any better. It's just 2 times 3 times 10. And that's 60. And again, the units are cubic centimeters because it's centimeters times centimeters times centimeters. And then what do we do? Well, Patty tells us what to do. She wants to add these two, because if you take the volume of this piece and the volume of that piece and add them together, you get the volume of the whole thing. And so what we want to do now is actually just add those numbers, and that's really straightforward. We just take 48 and we add 60, and we see 108 cubic centimeters. And that is the answer. So the volume of the composite figure, this is called the composite figure because it's composed of two familiar figures that have been kind of jammed together. This figure and that figure jammed together made this composite figure. The correct dimensions that we want to look at, in fact, are what we've already figured out, which is 2 times 3 times 8 and 2 times 3 times 10. And so what we see is that Patty's small error was the fact that she overcounted the volume of that kind of inside portion. When she took the 8 and then added the 3, she found the volume all the way out to there, but then she found the volume all the way out to here, so she double counted that. So this is a little bit too big. But great guess, because she was really thinking through it, but she wasn't thinking through it all the way. She could have made it a lot simpler by just thinking about taking a saw and then just cutting this piece away right here, and then having this piece right here, and then finding the volumes of each of those separately, which is exactly what we did. So Patty was a terrific teacher, and she really not only guided us to the correct answer, but she guided us to a classic mistake. When we're doing these interesting questions, especially questions involving volumes of composite figures, it's really important to think about what composes these objects and to pull them apart carefully, make sure that we're counting all the volume and we're not double counting any particular volume. Armed with that, and those familiar formulas, for example, for the volume of the rectangular prism, we can't go wrong. Have fun trying to find the volumes of composite figures in your life, and I'll see you soon.
All right, well, that was really great.
By 3.
Here's what I want to do. I want to try solving it the way Patty did.
The problem that she made...
Let's pause him right there. Okay, so Professor Berger broke it apart in a very simple way. Actually, let's see if we can get this.
It was this little area right
in
here.
Little bit bigger.
When she was clever enough to take the 8.
All right, is that a little bit better? Can we see those dimensions? It's a little fuzzy for me. Let's see if we can keep
3 to get the 11.
If we can find it.
That we're going to actually.
Is it me? Am I not wearing my glasses? There it is. Pause. Perfect. Okay, so now we can clearly see those dimensions. So what I want to do is I want to show you that we could still find the answer cutting the boxes like Patty did. Now, Professor Berger cut them in a very smart way. The reason he did it this way is because this dimension is already labeled for you, and this dimension is already labeled for you. So you don't even have to add or subtract or do what Patty had to do. Remember, Patty had to take that 8 and she added the 3 to get the 11. So sometimes just thinking through, you can avoid that kind of problem. But you know what? I want to show you that we still can solve this problem by using Patty's way of thinking. So Patty said that from this corner to this corner, it's 11 centimeters because she added the 8 and the 3 and got 11. So the dimensions on figure A, let's call that figure A, is 2 times 3 times 11. Absolutely right. So the volume for figure A is 2 times 3, we've got 6, and 6 times 11 is 66 centimeters cubed. But her mistake was she accidentally, that looks like a 13, doesn't it? Let me fix that to a B. She accidentally double counted that space, but we're not going to make that mistake, are we? Let's take a look at what our dimensions are. Well, we know this length is not going to be 10 anymore because we cut part of that off. We cut this part off. Well, how much did we cut off? If this little piece is 3 centimeters, then this piece is 3 centimeters. What is 10 minus 3? It's going to be 7, right? So for this one, the length is 7, not 10. It's 2 times 3 times 7. That's her mistake. Now we can find the volume using these correct dimensions. 2 times 3 is 6, and we know that 6 times 7 is 42 centimeters cubed. And then we simply add them together. And I'm sorry that my numbers are so big and clunky. My stylus stopped working, so I'm actually using my fingertip. That's not working out too well, but you know what? We'll make do with what we have. And this is those are dimensions for B. 6 plus 2 is 8, and 6 plus 4 is 100, right? 60 plus 40 is 100. Altogether, centimeters cubed. So you're still going to get the same answer no matter which way you break it apart, as long as you're careful to not double count this little spot that Patty did. Okay, here we are at the Khan Academy video.
Let's see if we can figure out the volume of this figure over here. And they've given us some of the dimensions. We see this side over here is 2 centimeters, this is 7 centimeters, this is 12 centimeters, this is 5 centimeters, this is 3 centimeters. And so like always, pause this video and see if you can figure it out. Well, there's a bunch of ways to do this, but the way I'd like to do it is just to break it up into 2 rectangular prisms. So what I'm going to do is, in fact, most of the reasonable ways to do this would be to break it up into 2 rectangular prisms. And the ones that jump out at me is one prism like this, that is 3 centimeters wide, 5 centimeters high, and then it is 7 centimeters long, or 7 centimeters deep. So this one right over here. And if this part right over here was transparent, you would see it look just like this.
Oh, I like how he does that.
Just like
that
this.
Really made it clear for me.
So this one, once again, it is 3 centimeters wide, 7 centimeters long, 7 centimeters long. So this distance right over here is going to be the same as this distance right over here. So 7 centimeters long. So the width times the length times the height, it's 5 centimeters. Gets us to, let's see, 3 times 7 is 21, times 5 is equal to, 20 times 5 is 100, 1 times 5 is 5, so it's going to be 105. And we could say 105 cubic centimeters, because you have centimeters times centimeters times centimeters. So this blue part right over here, this blue rectangular prism, has a volume of 105 cubic centimeters. So now we can separately figure out the volume of what I am now highlighting in this magenta color. If this was transparent, you would see this.
Wow, I really like how he makes this clear.
So what are its dimensions?
You can clearly see it's 2 separate rectangular prisms now.
Centimeters. We know that this dimension right over here, I guess we could say its depth, we could call it that, is 7 centimeters. But what is this right over here? If we want to consider this, maybe its length, or maybe its width, depending on what we want to call it. Well, let's see, this whole thing is 12 centimeters. From here to here is 12 centimeters. And we know that from here to here is 3 centimeters. So this piece right over here, must be 9 centimeters. So that must be 9 centimeters is this distance right over here. So the volume of this magenta part is going to be 9 centimeters times 7 centimeters times the height times 2 centimeters, which is going to get us, let's see, 9 times 7 is 63. 63 times 2 is equal to, 60 times 2 is 120, 3 times 2 is 6, so it's 126 cubic centimeters. So the total volume of the entire thing is going to be the volume of the magenta stuff, which is 126 cubic centimeters, plus the volume of the blue stuff, plus 105 cubic centimeters. And that's going to give us, for the entire figure, 6 plus 5 is 11. So 1 plus 2 is 3. Or it's really 110 plus 210 is 3 tens. And then 100 plus 100 is 200. So we get 231 cubic centimeters is the volume of the entire thing. Fascinating.
Awesome. Okay. Nope.
Let's see if we can figure out the volume of
Come
this,
on, pause, my friend.
figure over here. And they've given us some of the dimensions. We
Pause.
see this side over here.
There we go. Okay. All right. Well, great job. Now what you need to do is go on to practice with your iReady lessons. Make sure you get those done. Remember, if you fail it, go back and watch the videos again, do some more practice, and then you can take the iReady lesson again. If you fail it a second time, you have to email me and ask me to reset it for you. I'll have to assign it all over again, and then you'll get another 2 tries. And then tell me that you've passed it so I can go ahead and change your grade. All right? You can do it a million times if you want to. If you're not happy with a 75%, tell me and I'll change it. I will reassign it for you, and then you can do it again until you get a better grade, because this is going to be your report card grade. Your report card grade is your iReady lessons and your iReady usage. This is a great opportunity, boys and girls, to get an A or a B on your report card. Because unlike in the classroom, here you can do it over and over and over again and really learn those skills and really shine. So I want you to do your absolute best. And you know what? It's okay if you have a 75% and you want to keep that 75%. That's absolutely fine. I think C's are great. But if you got a D, if you got like a 60%, or if you've got a 50%, you know what? Tell me and we'll reset those over again. Because I really don't want you to have the grades that you don't think reflects how well you can do. I know you guys can do very well. You just need to be using a piece of paper and a pencil. Really important, I know I've said this to you before, but I do want to show you again. Make sure that you are doing those iReady lessons. Because, for example, let's say you got a 68% on one of those lessons, and then you got a 0 because you didn't do the lesson, and then you got a 100% because you did all 50 minutes. When you add them up, you get 168. Now, because there are 3 assignments, it's going to be 168 divided by 3. And we know 3 goes into 16 5 times, because 5 times 3 is 15. That means 1 left over. We bring down that 8. And I know 6 times 3 is 18. So your grade will be a 56%, which is an F. That's what's going to happen when you have a 0. But let's think about what would happen if we had a 68, and let's say we failed it and we got a 50%. So we still failed it. This one is failing and this one is failing, but at least with this one we tried. And we have an 8, nope, get over there. We have an 8, and 6 plus 5 is 11, and we have 218 in this case. And it's still the same 3 problems, or 3 assignments. And what number times 3 is 21? It's going to be 7, right? Bring down that 8. Now, 3 times 2 is 6. And what's going to be left over is going to be 2/3. And with grades, if you have more than half, we're going to round up. And 2/3 is more than 1/2. So that 72 is going to become a 73%. Big difference. That is a beautiful C. Do you see the difference? Even just failing an assignment is going to be better than not doing it at all. That's really important to know. And even if let's say you have a hard time getting this 68%, let's say you got a 50% on both of those assignments. All together, you're going to have 200 points, right? And if we do 200, I'm writing all over his page, divided by 3, what number times 3 gets me close to 20 without going over? It's going to be 6, right? 6 times 3 is 18. And when I subtract, I get 2 left over, and I've got 20 again. So it's going to be another 6. And I have 66 2/3. And remember, when it's more than half, we're going to round up. So it'll be a 67%, which is a D, which is still better than that 56F. So even if math is not your strong suit, if you still need to practice some of those skills, that's okay. But at least try it. At least try it, because anything is better than a 0. All right? Now, let's say that you got a 100% for doing all of your 50 minutes, and you got a 50% and a 50%, and you said, no, I don't want that D. So you email Miss Allison and say, Miss Allison, could you please reset these 2 assignments? And when I'm done with my current week's assignments, because that comes first, put first things first, then I'm going to take some extra time and I'm going to redo these assignments as best I can and bring those grades up. And then you email me and say, Miss Allison, I passed this 50%. I went up to a 75, or I went up to a 68. And I will change your grade, and your report card grade is going to go up. Okay? All of this is being done for you. But you have to do your part. You have to do this, and you have to do this. This is your job, to do your work and to learn. And then I'll do my job by checking up on you, helping you out, making all of these videos available. And if you just absolutely cannot get it, let me know. And I'll look for some different videos to help you out. Or maybe I'll make another video to try and break it down a different way for you. I'm here for you. I'm here to help you as much as I can. All right, get to work, loves. I'll see you next time. Bye.